I walked in and there was a gold car racing and he looked at me like, "You okay?" And I'm like, I know. It was like people do that. I don't know. It really bothered. Oh, I'm sorry.
No problem.
I smile. Sorry, you have money. Oh, so my phone. It smells so
Good afternoon. Thank you. So we are beginning. When the music stops, that means we are beginning. I do want you to take some time to just take a look at the dates, think about it for a second. And discuss how you're supposed to do that problem. After you think about it, of course. Date. Okay. Does anyone have any insight into this? Right, you can't say like 34 squared. Okay. So we know 10 squared is 124 squared. Do we know what 24 squared is? So we could do it that way. Any other ideas? Where else do you see numbers squared? Pythagorean theorem. Is it possible that this be part of the Pythagorean theorem? Well, get it there, but I hope it makes sense that if you have these sides, you're doing this problem, wouldn't it be x squared is equal to 10 squared plus 24 squared? X is equal to x squared plus 24 squared? Yes. So like we're saying, you kind of break it down to 5, 12, 13, and that's how this answer is 6. Rather than going through the tedious calculations. Or fun calculations if you like that stuff. I want to remind you that there is a sign up there. Oh, I don't know if it's a new sign. No food or drinking allowed in the classroom. Water is okay. Look what we have here. Ants. We don't want ants here, so please make sure you're not eating or drinking. I didn't draw them. Yeah, they're printed into it. Very nice touch. What's that? Mr. Lopez. Yeah. Pretty skillful with the graphic art. Okay. So I hope the homework is going well. I look at what you're doing, and most of you are staying on top of it really nicely. Let's just get through the lesson. Maybe some kind of class. Shall we do that? That's kind of preferable, isn't it? To do some work in class. You get the practice in class, and you get more sleep, which is a good thing. Okay, so linear equations and rational equations. Today we start. Okay, you too, please. Today we start solving equations. You know what a linear equation is? It's a linear function, right? So it is directly involved. So it's an equation that has a degree of no more than 1. It's got the mx. No more than n. I don't know if I should define this. Yeah, well, I'll write it. An equation x. Oh, wait. Equation whose variable has a degree of. So it's just like polynomials, compared to the degree of polynomial is 1, then it is a linear polynomial. There are a few different types of equations. There are identities. Is that something familiar? Identity? What do you know about identities? What equations to remember? Can we just check in with your neighbor and see if they know any of these? Conditional. These aren't properties, these are types of equations. Anyone have any idea? Okay, you're right. We know these words. We're familiar with them in terms of properties, but in terms of class of equations, what do you know about an identity, an equation that is an identity? I'll give you the most easiest example. The easiest identity is x equals x. You know what the solution for this is? Could be 1 or 2 or negative 200. Oh, an identity has infinitely many solutions. And it's not always going to look like that. So it could look something like 3 times x plus 2 equals 3x plus 6, right? That's also an identity. And if you were to solve it, you're going to get something like 0 equals 0, or 12 equals 12, or negative 9 equals negative 9. If it's an identity, there are infinitely many solutions. Infinitely many solutions. I'm going to say all the numbers. Solution. All real numbers. I'm going to skip conditional, but you know the word conditional is from what class? Geometry. What was a conditional statement in geometry? If then, right? If. What's the letter they use? If. And the converse of that would be. Okay. Inverse. What's the other one? Okay. The contrapositive, if not. Not B. Which one of those are you? Contrapositive and the conditional, the basic, which means the converse. Logically. But I digress. One on the tangent there. Let's get conditional for now. Go to inconsistent. Inconsistent is an equation that has. I'll give an example. X equals x plus 1. What number is equal to the number after it? Isn't that what that question is asking? What number is equal to the number after it? And of course, we know that the answer is no solution. And you can see if you were to try to do something like algebra your way out of this, you get something like 0 equals 1, which I think is false. If you end up with something ridiculous, then the equation itself was inconsistent. And when it's inconsistent, there are no solutions. Which only leaves one type of equation. I'll give an example. The x plus 1 is equal to 4. This equation is true if x is equal to 1. Right, that if part makes it a conditional equation. I know, so exciting. Solve each equation, determine whether the equation is an identity, a conditional equation, or an inconsistent equation. I'll give you a moment to work through these. And we're solving it, then classifying. Let's do 8 together. How many of you do this? You do start not doing that. That's a waste of time. I'm not gonna take off for doing that. And you may do it, but I recommend highly just doing this. If I ask you how you went from one step to the other, you say you subtracted 3. Next one, x equals 7. Not have the little line. Of course, what kind of equation is this? Conditional. It's true if x is equal to 7. Abbreviation for equation. It's I think the consequences. Yeah, but they're coming. Yes. Okay. Imaginary thing. Okay, for B, I'm just gonna go through this. 4x equals 24. Did I do that right? 6. So we know this is conditional. X1. I need some help. Make the lines up. Some time to discuss. Go ahead. Did you all navigate that the dangerous waters there? You know what I'm talking about, right? Plus 11. Thank you. Keep on going. Excellent. It's simplified before I started moving things around. It's a really good habit. You don't have to like move that -6, move the -17, simplify first, and then start moving things around. That's what you did next. Nicely done. Are we comfortable doing it the way Jojo did it here? You could do it one step at a time, but I'm a big fan of just combining all the like terms, just like you did. Like add the 3x to both sides, add 23 to both sides, and just get on with your life. But if you need to do it a little bit slower, you may. Thank you. Oh, we have these fun ones down here. Yes, Kara. Four. You said 4x plus 4? Negative. Oh, negative. Where did the negative 10 come from? Oh, did you like do a whole bunch of stuff together? Okay. Do you mind if we, yeah, get that 14 first? Thank you. Okay. Are we good with that? Yes. Ah, maybe. Is that what it is? Move the x's to the other side? Oh, that should be a negative tension. Yeah, you just choose one method. I think you did great. I think you just made that little sign error. If you have that negative 2x on this side, you're moving the x's to the right, which is fine. That means negative 10 here. So our answer is, thank you, is positive 5. I'm a big fan. Here, I have to compliment you in just how you finished. Thank you for not ending in 5 equals x. If you're solving for a variable, the last step needs to be x equals that thing. I want to know what it is. So start with, no matter what side it is, switch it around. Like you could have easily gone to 5 equals x, but you switched to thank you. Personally, I would have chosen to x's on the left only because that would have kept it positive. That's positive. But it really doesn't matter. Just be careful if you're bookkeeping as you navigate these. And F 80. 2x plus 2. Okay. Okay. Inconsistent. And if I ask for a solution, then you would say no solution. Well, if it says solve each equation and your answer is inconsistent, does that do the job? It doesn't do the job. So even though I know what you mean and I want to give you that full credit, please make sure you're answering the question completely. Now, would you always have to say inconsistent if there's no solution? Only if it asks. Otherwise, I couldn't care less. Normally, I won't even ask you about that. It seems kind of unnecessary overall. Are these linear? The power is 1. Yeah, so they're still linear. How are we going to do this? Care, what do you think? Nice. We're going to multiply both sides by 14, and you chose 14 because exactly, least common multiple. It cancels all the denominators, and we could do that since it's an equation. Multiply both sides by same number. And sometimes you get confused, and if you see this, and so you may just say, I'm going to multiply by 7. You can't just multiply by a random number if it's just an expression. If it's an equation, you can multiply anything on both sides. If it's expression, you can multiply anything top and bottom. But please make sure you multiply both sides for an equation. So let's see what this leaves us with. I think we have 28x minus 7 goes into 14 twice. So we have 4x equals 2 goes into 14 7 times. Plus, did I do 17 times 14? No, I do 17 times 7. Which is 70 plus 49. 119. That's not nice if they made us do that. You shouldn't have to do arithmetic more difficult than that. If you find yourself doing arithmetic that's really exhausting, you're probably taking the long route. Okay, now you can see it's much easier to finish. I'll give you a chance to finish that one. H, I, and J. Make sure your neighbor's doing okay with these. Jojo Mackenzie, don't forget you have Chloe behind you. So you're checking one another's answers.
Yeah,
Check in with the neighbors. Okay, ready or not, let's finish these. Who could help finish off G? Okay, I'll do it. I'll just add 4x to both sides. No, that's a terrible idea. Let's simplify the left. 24x equals 7x plus 119. Next step, subtract 7x. So this becomes 17x equals 119. Does 17 go into 119? We just did it? Oh, so what does it equal? Oh yeah, we did do that, didn't we? Equal 7. Now, if you're not sure and if this is a test and you just don't have time, do you know what to do? Just leave it. So just leave it like that. If you're just not sure and you need to get to the next problem and you don't want to work through the division, leave it like that. It's called calculator ready. And sometimes it will simplify, sometimes it won't. But you're right. We already saw that this was equal to 119. So we could reference what we had before. This equals 7. Yes. Yes, you would get points taken off, but at least you would have hopefully significant portions of other problems done. So it'd be a sacrifice. Yeah. Thank you. Good question. Fractions do have to be simplified to get full credit. H, I need some help. Yes, Mimi. Are we good with that, everybody? 30? So you do left and right at the same time. Okay, what happens in that first fraction? So we get what's that? 18x. Okay, 6 and 3 is 18x.
It's 15x plus 45.
Ooh, Do y'all get that plus 45? Keep on going.
10x plus 20.
10x plus 20. Okay.
And 3x plus 45 equals 10x plus 20. And then you can subtract, so it's 7x on one side and then 25 on the other.
Do something like this. Are you comfortable with that? Did you do it like this or did you do the other sides? Okay. Yeah, it's safer on the other side for sure. But if you want to start putting your x's together on the left, you may. 25, you said? Okay. 25 sevenths. Should I change that to mixed number, you think? No. Please don't waste your time doing things that are unnecessary. It would change to a mixed number if it's a word problem. This is definitely not a word problem. Thank you very much. And both, of course, both of these equations are called conditional. They're both true only if that number is replaced in that x. Should we check this? Should we check to see if this is right? Mackenzie, I'm with you. That just seems painful to do, doesn't it? Yeah. At some point, you just got to trust good work and trust that if this were a test or quiz, I'm at least going to give you partial credit, even if you totally messed up. Is it possible an answer might be a fraction on a test, though? Yes. Elise? Yeah, no need to even do anything. Right. Yeah. Yeah, once you know it's inconsistent, I'm okay with you just saying it's inconsistent, and therefore, what do we know about solutions? No solution. I usually abbreviate solution as SOL apostrophe N. J. Yes, Haley.
First on the right side, so you keep like 7x plus 9. And on the right side, it's 9x plus 9 minus 2x, which becomes 7x plus 9. And then it's the identity, because it's like all the stations.
Yeah, it's you don't need to keep going. Once you see it's exactly the same, you could say, like you said, identity, and therefore identity. Yes, some indicator that there's all real numbers are solutions. X could equal any real number. Should we check? Everyone plug in a different number and see if it works? There's no need. Are we good? Yeah, okay. Rational equations. What do you think is the main ingredient of a rational equation? A rational expression. Would you check to see if your neighbor remembers the difference between a rational number and a rational expression?
Rational number. It's a rational number. Yeah.
A rational number, a rational expression, what's the difference? A rational number, of course, is a number that can be, I feel like deja vu right here. Written as a ratio of integers. Rational number, a rational expression is an expression that is written as, yes, Isla. Exactly, a ratio of polynomials, the bottom has to be at least 1 degree. Yeah. So were these up here? Were these rational equations, you think? Wait, where am I? This one. Was G a rational equation? No, this is a linear equation. It's not rational because the bottom, to be rational expression, has to have degree 1 or higher. So it looks like a rational equation, but it's not. It's an imposter. So a rational equation is, should I say it? It's an equation involving rational expressions. which seems it violates all sorts of definition making conventions. There could be one, or as long as there's a variable in the denominator, we know it's a rational. It is a rational equation. Okay. Hey, these guys, those are definitely rational equations, and we're going to do it just like we were doing before. Eliminating all the denominators, my recommendation is just multiply by whatever you need to eliminate the x, the 5, and the 2x. Namely, check with your neighbor, what are you going to multiply both sides by? Basically, I feel like you've seen this before. Multiplying by 10x, is that right? And notice I put my multiplication a little bit at the top because it's implied to be like over 1. And I like to set up the canceling. I'll give you a minute to finish.
That G wasn't a rational equation.
And because it's you need a degree 1 in denominator. So you have like 2, that's a degree 0 there.
Oh.
Check in with your neighbor.
Oh, all right. Yeah, they remember.
That's,
Okay, who could talk me through it? I'll just do this first one. 10x times 1 over x, of course, is 10 by design. There's no more denominator there. We have to distribute here. 1/5 times 10x is 2x. And when I multiply this times this, in my head, I'm just doing this. So x's cancel, 2's cancel. Was 15. Did I get that right? So we have, I'm going to put this over here. X equals negative 5 halves. Did you already have that? Are we classifying these? We're checking though. Now, if it says to check, you know what that means. Okay, if it says do it, I'm going to do it. Okay, so first of all, if this is a test or quiz, I want to make sure that I have my answer boxed so I know exactly where to look because this is about to get messy. Here's my check. Let's check. I'm going to plug it back in. 1 over negative 5 halves equals 1/5 plus 3 over 2 times negative 5 halves. I like to put a little question mark here. Are they actually equal? I'm just checking. 1 over negative 5 halves is negative 2/5. 1/5 is 1/5. This is kind of nice in the denominator, isn't it? 2 times 2 times negative 5 halves. Let's do cancel, leaving us with plus 3 over negative 5. So I can think about this as 1/5 minus. Did I mess up? Did I mess something up? Oh, not plus. Thank you. There should be equal sign. Thank you. Oh, that's bad. So are these equal? Yeah. So when you're doing this, I do want to see that both sides are equal to one another, and that's your check. I hope this makes sense. I'm checking. I'm not sure if I did it right. I put a question mark there. Put a question mark there. I want to see that they're exactly equal, even though I can see it here. I want to see that final statement, just the number equals a number. There's no doubt about it. I'll give you a moment to work on B.
Yeah.
Okay, I'm 100% sure. It's X minus three.
Isn't it supposed to? Question.
I need to get rid of it. Yeah, you gotta get rid of this one too.
So B. What do we do? What do we do with B? Multiply everything by 18x. Again, I put it kind of towards the top. So the left side, we're left with 9 times 5, 45 equals 17x minus 6. And you can see it's such a much more pleasant problem once you do that, isn't it? Please, we call this clearing the denominator. So make sure to clear the denominators anytime you're dealing with a rational equation. I'll add 6 to both sides. 51 equals 17x. This is every math teacher's favorite question. How many times is 17 going to 51? 3 times exactly. It's not prime. Now, if you didn't know that and you're in a time crunch, you would leave it as 51/17. But x equals 0. Oh, it said to check it. Should we check it? Let's check this one and not the other ones. Oh, okay. Okay. So it's gonna be problematic. So check. So 5/6, does it equal 17/18 minus 1/9? Is this true? I think I could keep this side just 5/6, and then 17/18 minus 2/18. So it's 5/6, and there are different ways to do this. Is this true? Yeah, 5/6 is equal to 5/6. Yay. Okay, for C. Did you already do this one? Let's do it together. We're going to multiply everything by x minus 3. Left side becomes x. The right side becomes 3 plus 9x minus 27. Did I do? Oh, no, I did that. Did I do it right? Okay. I feel like something's strange here. Okay, so what happens? I guess I combine these. We have 3 minus 27 is negative 24. Plus 9x. This is awkward. Negative 8x equals negative 24. So x equals 3. Plug it back in and yeah, we have a problem that 3, if you look at it originally, 3 is actually not in the domain. It's a restricted value. We have to cross that answer out. What's that called when you get an answer, but you have to cross it out? It's called extraneous. That is extraneous. So this, what kind of equation should we call this? Inconsistent. Therefore, there is no solution. They want to see a different way. I think it'd be done a little bit easier. Do you see what I'm talking about? Starting over. Do you see it? Do you see an easier way to do C? Like instead of clearing the denominators? Yeah, maybe you see it.
Subtract 3 over x minus 3 from both sides, and then you just get x minus 3 over x minus 3.
Yeah. Right, equals 9. Or 1 equals 9. So we can see right there. Inconsistent. So our answer is consistent in that there's no solution, but that's just a nice way to do it since there are common denominators already. Should we do that for D also? I think it works out pretty. I'll let you do that on your own. We have all these. Okay, I'm gonna go over these at 2:30. Now I'll give you time to continue working at 2:30, but I'll give you a little time to stretch or talk.
Oh, yeah. And you listen up and it's actually working. Okay, great. Well, I need to play everything by 3 and 6 and 2. Oh. I like Jay. This is. I'm not. Oh, I know. I hate you. This is like going back to 3rd grade. There's no satisfying. I'm so happy we didn't know their trouble. But they would say no. No, because like, you don't take it. Oh, but love it. Oh, I saw. You know, I don't know. I don't know if it's something on. I don't know if something is that. It's in 1 second. No, it's small to me. Did you see the? I can't see it. No, I know that's. Still with this one, which is. I don't like that this. I don't know doing this, so. I don't.
I permit like the second.
We're numbers. I don't Wait. Oh. Already? Maybe they're using that as a variable. No, it says like a poor choice. Oh, whooping. Or complex project. Where is it? It's right after. That's right back. It's not there. Oh, yeah, 1.4. Yeah, imagine right number. It's here. Oh.
Okay, let's finish this up, shall we? Let's get right to it. Back to it. Okay, if you use the method we've been using, these problems are pretty straightforward and they kind of work themselves out. So please make sure that anytime you see this, you're not trying to get a common denominator. You're trying to clear the denominators. And you see this x squared minus 2x minus 8. What are we going to do with that expression? Factor it. When you see a quadratic, that should be your first inclination. Factor it. So I'll leave these first as they are. I wonder what the factors of that last one will be. What's that? I wonder. Maybe some random things. Let's see. 2 numbers I multiply to be -8 and add to be -2. Oh, look at that. Look at that. My voice went up 3 octaves. I'm so surprised. Multiply both sides by that x minus 4 and x plus 2 on both sides. I'll let you finish this. Who's already finished this one? Wow. Nice. Check with your neighbor when you're done.
Oh, did you get it on?
There is danger involved. Did you survive the danger?
Last one?
Access to.
Yeah,
minus is that. I did this.
Okay, I need some help. Who could talk me through it? Care for 300.
So from there, I did the, wait, no, wait, okay, so then I multiplied everything by, x plus 4, sorry, x minus 4 times x plus 2.
Okay,
I got x plus 2 minus,
just a minute. Are we okay with that? X plus 2. Everyone's okay with that? Okay, keep on going.
x plus 2 minus the quantity of 5x minus 20,
I'm gonna leave it separate if you don't mind.
5 times x minus 4.
Are we okay with that? Or with that danger, with that minus? Now you could skip that step, but I'm gonna just play it safe here. So equals just 6, that's it? Oh, that's nice. Okay, so this becomes x plus 2 minus 5x
Oh,
minus 5x.
had them in the thing.
Okay. So eventually you got there. Okay.
Subtract 20 each side.
Before we do that, I want you to take a look at that left side. It's a mess, isn't it?
Oh, yeah. So then I have 4x, sorry, negative 4x plus 22 equals 6.
Okay.
I subtract 20.
6 minus 22, is that negative 16?
So then I had x equals 4.
Would it be appropriate to just leave the 16 over 4? You better know 16 over 4. Unless your name is Kyson. You didn't have a Kyson pass. You can't do simple math. No problem. Any questions? Oh, Kara, that was great.
That's extra.
It's extraneous? The x can't equal 4? After all that? Seriously? You're gonna do that to us? It happens. And it was so satisfying. We got a number and everything, but yeah, I can't use it. So always go back and check the domain. If you get a number that's out of the domain, it's gotta go. Kick it to the curb. Is f even rational?
I don't.
Is f is it rational? Seems like it would be irrational to do that one. I'm gonna skip it. Oh, what is the answer though?
Why?
It's not irrational. It's just it's not rational. Because the denominators are all numbers.
So what is that irrational expression?
Oh, good question. What would we call f?
It's just like a regular, what's it called?
What is it? It's linear. It's linear. Yeah.
Yeah.
Yeah. To solve it, you would do the same thing. You multiply both sides by 6 and continue. And what do we get in the end just for -7 is the answer? Okay. I highly doubt that.
Negative, but got different answers.
Was it, did either one get -7?
That it's not rational, that's irrational. Rather keep solving it.
Oh, yeah. I'm just being lazy.
Yeah. Okay, then G.
Would it be helpful for me to do this?
No, I think you want to do it to take both.
No, I got -7. I like realizing.
Okay.
G is extraneous.
X squared -9. Keep it together, folks. Okay, we're just gonna multiply by.
X plus 3, x minus 3, then you get 4x squared.
Would you be comfortable doing this?
That's too tough. Let's get separate.
Would you be comfortable doing that?
No.
No? It's up to you. I don't know. It's the same thing. So it's up to you. It's at your pace. It's fine. So x minus 3 and x plus 3. A little too advanced? Okay. Maybe. I'll do it. I'll keep it with the factors. X minus 3, x plus 3. This one, we get
Minus 12x, minus 12x.
I can dial it back just 4x times x minus 3. I hope you don't mind that. And then minus 12 times.
Um,
Are we good with that? Because I did notice on the last test there were issues of people trying to go faster than they're comfortable with. And if there's any doubts, just take it a step at a time, please. Once you have the chops, yeah, go for it. Don't skip too much though. On the right side, we're left with so you factored it. I'm just gonna leave it like this. Kyson, can you finish it up for us, please?
X squared minus 12x minus 12x minus 36 is equal to 4x squared plus 36. That's not.
No,
You're doing great.
that expression is wrong.
You're doing great. Don't listen to the haters.
That expression
Okay,
is
can
wrong.
you stop talking? Did I do that?
No, I'm saying you did it right. but
Oh, yeah,
it's
yeah,
like that thing.
And then it's like negative 24x is equal to 72.
Oh, so these is gone. Gone.
Then it's,
Negative 24x.
and x equals negative 3. When you plug that back in, that's like extraneous.
Oh, they did it to us again, huh?
4 times in a row.
I don't know. I would not have known. 4 times in a row? Would it be a good idea just to say no solution anytime you see a problem like this? Yeah, that'd be ridiculous. Okay, and I think there's one more. Okay, consider these equations. So these are called functions. Functions are relationships that have inputs and outputs. If you want to find where they're equal to each other, well, you just set the y1 equal to y2. So 3 over x plus 6. Bye, Haley. Equals 4 over, what should I do with that? X squared plus 4x minus 12. Accurate. It kind of sets you up for it. Yeah, yeah. We have to.
Yeah. Then you're just.
Yeah.
Yeah. Then you're just.
Yeah.
Might as well get
Did you finish this one already?
Like go a little slow.
Okay, I'll give you a chance to finish it. It is, I'm sorry. It looks like a Disney 4.
I got the same deal these ago.
Uh-oh. That's really good news. For the 18? The 18? Okay, good, because that's not the answer.
So do you want your
X. Yeah. That doesn't matter.
The fast doesn't mind, the most does mind. Yeah. Okay. Guys, what you watching?
I told you 104 X.
Oh, you did. No, you don't say that. You don't.
That's what I thought.
Okay, I need some help.
Division.
Anyone who hasn't done it yet, want to help us through? Anyone who's done it, want to help us through? At least, thank you.
So, 3 times x minus 2.
I think you're multiplying both sides by,
My God. X plus 6, and then x minus 2.
okay,
So for 3 over x plus 6, x plus 6 comes out, we get 3 times x plus 2. And then for the 1 over
x minus 2? Okay,
oh, yeah, x minus 2. And then for the 1 over x minus 2, x minus 2 cancels out, you should just have 1, so you can just already write x plus 6.
oh wait, so x plus 6, okay, thank you.
Both of them cancel out the last one, so it's just 4.
Okay, well, that's nice.
Three x minus 6 plus x plus 6. The x's, the sixes cancel out, -6 and 6 cancel each other out. And 4x and 4x equals 4. And then else.
Or if you're Kyson, or 4/4 if you're Kyson.
Great right there. No use.
X equals 1, and that's okay?
I think I did the problem a little wrong.
No, he got the same thing.
Okay, now let me make sure that we've answered. So find all values of X for which this is true. I think we got them. I hope this has made sense today. And as we hoped for, you have a bunch of time to work through the first part of your homework.
Or not what time, start work.
2:42.
I was so happy. Well, we should leave him in the bathroom.